And I'm the software team lead.
I'm Jose Ortega. I'm the current project manager.
I'm Chris Pritchett. I'm the chief engineer for this year.
And I'm Chris Stan. I'm next year's chief engineer.
And we're here to show you how we innovate, how we inspire innovation of autonomous systems here at UCI.
Just to give you guys a quick overview of what we'll be covering. We'll cover what the project is, sort of our goals and overview and all that. Then we'll cover what we've done this year and what we've accomplished. We'll move into what we learned from all that and what changed over time. And then these guys over here will talk about what they're planning for next year.
So, brief background. So, DARPA put out a competition a few years ago to crowdsource UAV innovation. The overall goal was to build an aircraft, whether it be a plane, a helicopter, or anything in between for long-distance surveillance missions. Out of the many specs, no one was able to complete every single one. So last year, a few students here at UCI decided to make this competition a senior design project. Last year started off as a few MAE students, but since then we have crossed into the School of ICS, making this a really multidisciplinary project. I currently work on the fabrication, but because of this, I've been exposed to how stereo cam works and how LiDAR works and our optical avoidance algorithms, and just stuff I normally wouldn't have been exposed to as a regular mechanical student. So last year was our first year. We first built a quadcopter, and since then we've been working on that alongside our other platforms. We started off fall quarter with building a regular plane. Almost everyone left. It was me, Chris, and a few others. So we built a plane to get that manufacturing experience. We flew it and we crashed it many times. And winter quarter, we decided to build off that platform and move into VTOL capabilities. So we added a tilt rotor. We added 2 tilt rotors to the end. We managed to fly that fixed flight. Something to notice were some oscillations from the heavy point masses at the end from the motors. And we attempted to hover, but that proved unsuccessful because of the imbalance of weight along the quarter cord. So this spring we moved on to our newest platform right here, titled the Sledgehammer. And if you're wondering, it's because all our planes are nailed into the ground, and we sort of just built off that since then. So we built this quarter. It's a quadcopter and a regular plane hybrid with the 2 tilt rotors at the end, but in order to help stabilize from the previous plane, and what we learned is we added 2 rotors for VTOL.
Placement of this table isn't perfect, but to cover the hardware solution on board the plane, what we've got is the Pixhawk, which is a flight control unit that we've written our own software on, and this allows us to control all the actuators on the platform. We've got boards on board the plane, and those allow us to process all the sensor information and sort of build up intuition and knowledge about the environment so that the platform can react to it. We have this LiDAR here, and this LiDAR is very small, very light, but the cool thing is it can detect objects up to 20 meters away in all directions at 40 hertz. So we use that for long distance obstacle avoidance. And then we've got these 2 cameras here, stereo cams, that will be located on the wings. And these guys provide depth, color, and object information. They don't see as far as the LiDAR, but they allow you to collect information about the environment and do a lot more when things are closer to you than with the LiDAR.
On the software side of things, we have implemented a fully functional prototype of a ground station from scratch. And what it allows us to do is enter some basic information like waypoints, send that information to the UAV, and store some data that is specific to the mission. Also, it allows us to stream live video directly from the UAV to our laptops. On the right side, you can see it shows the software solution we have on board of the UAV, and what it allows us to do is get the data directly from the LiDAR, and using our pathfinding and obstacle avoidance algorithms, it allows the UAV to navigate itself through the environment autonomously.
So at this point, that's sort of what we've done up to this point. Just to cover what we've learned from this year, this is more of like a casual conversation. So like Jose said, from last year, we didn't have too many people returning. We worked on a quadcopter, but it wasn't quite, like, we didn't quite know what we were doing at that point. And so we sat down at the beginning of this year, we tried to figure out, like, make a game plan, figure out what we're going to do and try to stick with it. Obviously things changed anyways. But we spent that first quarter working on a plane because we had no idea what goes into designing a plane, building a plane, testing a plane, so on and so forth. So we spent fall quarter building that plane, figuring things out. Winter quarter, we decided to move back to the quadcopter. We made it a more stable platform. We wrote the controller from scratch and learned a lot, and it flies really smooth now. In fact, that's our first testing platform for our autonomy code. And this quarter, with this guy here, the picture up here, this was really a combination of the two. So it's half tilt rotor, half quadcopter, half plane, and we're sort of bringing together all of our conventional knowledge from the conventional platforms we've built and built something unconventional, something that we can learn from, something that's flexible, we can try different things out with. And really what happened, we had this grand goal of this tandem wing tilt rotor, quad tilt rotor plane that was going to perform everything we need for that DARPA mission specification. And I mean, we couldn't do that at all. We had no knowledge about how to do this stuff. So we spent the entire year sort of building up this knowledge, learning what it takes to do this stuff, and getting to the point where we can build something that hasn't been done before and be pretty confident that it's going to work out. So that's sort of what we built up to this year. And taking all of this and moving on with it is what these guys are going to talk about next.
Okay, hello again. So as next year's chief engineer, I kind of wanted to talk about what exactly the future holds for this project and what people joining this project can expect next year. So as Chris just said, we spent the last year learning pretty much everything. How to run the project, how to design planes given certain performance requirements, how to build planes, whatever software requirements we needed, what hardware we needed. So we've built a fairly decent foundation of knowledge that we can use to accomplish our long-term goals. The first of which is to next year finish with tilt rotor, which we have sort of affectionately dubbed Delta. And if you're actually curious about our naming scheme, all our platforms are just the letters of the alphabet, so Alpha, Bravo, Charlie, Delta. So it's Charlie. We've been researching and designing that tilt rotor for, I'd say, the past 6 months, and we project that it's going to take until the end of at least next year to finish, because there are some very non-trivial problems that we have to solve. Some things include flight balancing, around the quarter chord, controlling yaw, pitch, all that stuff. So that's something that's going to take a lot of homework to do.
And as you can see, this quarter we have all these different components to our project. And a big goal for next year is put all of these components together and actually achieve autonomy. Our problem this year is there's a big difference between testing our platform in a controlled environment and taking that and testing it in a dynamic flying environment. So that's a huge milestone for next year that we want to achieve. We want to take all these components and achieve autonomy.
Right. This next goal for next year is more on the experimental side of things. We want to create more experimental platforms because we've built up a good knowledge base about different modes of flight. So helicopter, tilt rotor, fixed wing, quadcopter. So we have all that knowledge. We can essentially find out which combination works best to achieve the best efficiency for what we're trying to do. So that's going to require, like I said, more research, and we're going to have to do our homework to justify the decisions that we make.
And, yeah. On the software side of things, we're trying to take the ground station that we currently have and optimize it. Also, we're going to add functionality to it as we go. Whatever is needed, we're going to add on to it. Another big focus for next year is learning machine learning techniques, getting all these data from our different experimental platforms, and trying to analyze the data and interpret it to some useful information that we can use.
Okay, lastly, just want to go over some opportunities that will be extended to students who join this project next year.
So we are one of the few true multidisciplinary projects here at UCI, and we not only bridge over engineering but also ICS school. This gives us the opportunity to have teams that go over different disciplines. So you as a future team member of our project will have the opportunity to not only work on the team that you're in, but also explore your interests in different teams. So you will be able to, there will always be people there to help you and guide you.
Yeah, so this last point, focused on innovation, is something that I personally love about UAV Forge. It's that we foster an environment where people can come in, find what they're passionate about, commit themselves fully, and delve as deeply into the knowledge as they can or as they want to. Again, if people join this project and they find something they're interested in, and they commit themselves and they put their heart and soul into it, we will support them 100% of the way. And that's not to say that we demand perfection. Mistakes can be made, mistakes should be made, that's how we learn. But if people really do what they want to do, and we have a lot of them, then this project will be as best as it can.
I don't know any questions.